Welcome to X Discovery support for AHV on new stuff. This is feat 12789, and X Discovery includes the application discovery and the VM relationships. App Discovery has been available for some time now, but just on ESXi clusters as part of the Prism Pro licensing. The benefit is it will automatically, out of the box, have rules to discover common applications. And it's doing this by listening to network traffic and identifying the ports that they're talking over. It's all agentless and works with our cloud engine. So it's pretty simple to get moving. So in this example, we've clicked on a virtual machine and then we've gone to the Apps and Relationships tab, which you can see in our image. And if you'd pick the apps one, it would look very similar to this, but it would just list out the apps that were discovered on the VM. This one we're looking at the relationships. So we can see our VM in the middle, much like you would on some of the flow diagrams. And then you have your incoming traffic or virtual machines that it talks to on the inside, and then also on the outbound side. So it's very easy to see who it's talking for inbound versus outbound. You can also see this in a table format where it just lists everything out in text by in or out by choosing from the drop-down menu, and that example is in the next slide. So these features are all the same of what's existed on ESXi so far. We're just now bringing AHV into the mix by doing the underground plumbing that was required for it. Hello, welcome to New Stuff for AHV Templates, feature 6568. If we examine what the problem was with not having templates on AHV in the past, historically AHV always had the image library, which was kind of like a template, but not really. It was focused on a single vdisk and really just cared about the contents of that vdisk, so you could easily clone it to make VMs from it, which was template-like. But it forced the admins to redeclare all the other requirements of the VM each time that they did that. So now with templates in Prism Central, you can now capture the full configuration of the VM into the template. So that's going to be everything from memory settings, CPU, networks, volume groups, and then provide the mechanism to do guest customization also, and Windows licensing keys. So you'll need PC 2021.12 and at least AOS 5.19.2 for this feature. So we're just taking a quick look at the screen captures of the flow for what it looks like to create a template from an existing virtual machines. So you can obviously see the naming is all in there for the template name and how you want to name the host name for the VM. Whether it's going to be domain joined, this is the Windows version, so there's a licensing key in there, and you can see the options for guest customization. These are the screen examples for creating a template from a VM for the Linux. So very similar to the Windows one, allows for guest customization, host name, etc. Just a slight difference in how you customize, Linux operating systems versus Windows. Now, one of the nice features of templates is they allow for a life cycle of that template image or gold image as it exists. So you have the ability to update, do updates inside of the guest OS. So if you select the template, as you can see in our example picture here, and then choose to update it, and then we'll go through that process in the next slides. So when we chose to update our guest OS template, what it's actually going to do is deploy a VM with that template image and all the settings. You can then log into that and then perform any updates, such as OS patches, application upgrades, whatever the changes that you wanted within inside of that template, and then when you're done, you proceed to the next step. So now that our changes are all done inside the guest OS, we can essentially close up this process, complete the OS upgrade. You can see once we chose that option in the Prism for this, We can now, change the name if we wanted. We can provide any notes, which would be great, such as what was done, like I applied Service Pack 1, I upgraded, Adobe Acrobat, whatever the example is, you put that in there. And then you choose whether or not you want to make this the new active version of the template, because you're allowed to keep multiple versions, but only one is active. And then you complete this process, and it's going to, shut that VM down, update your template, and make it available for consumption. So in Prism Central, when you're looking at templates and we click on a given template, the example that we're showing here on the slide from the UX is that we can see all the versions of this template. It's got 4 versions, so there were upgrades done. Some of the upgrades were to hardware, so we've changed the amount of memory. Others were just updates inside the guest OS. So that's where the note field will be incredibly valuable. And then one of these is just the active version. You can change that when you want, because that would be what is deployed. So you can do some upgrades and then not make it active, so that you're working ahead, and then once you want to deploy them, then you can make it active at a later date when it makes sense. And just a few known limitations. Obviously, this is AHV only function. If you're using ESXi, then you would use the templates that are long been available inside of vCenter. There is no CLI support for this feature. It is a Prism Central GUI only option, so there is no APIs for this at the moment. And it's an admin only inside the GUI, obviously, so there is no RBAC support for it yet. And then it works in the newest version of Prism Central, but you just need at least AOS 5.19.2 or newer to support it on the AOS and AHV side. Hi, welcome to Feat 2189 for new stuff. This is memory overcommit for AHV. Let's have a brief look at what memory overcommit means and what it's been like to this point. So historically, the problem statement was that VMs on AHV always had a fixed memory size. So if you assign them 4 gig, they were assigned all 4 gig as a fixed size. This is great. It was reliable performance, was easy to manage. But some use cases, such as non-production or development clusters, wanted more VM capacity, so the ability to squeeze more VMs in a cluster, and did not care as much about performance. So with memory over commit, we allow the host to take away some of the unused memory from VMs that are not using it, and then assign that to other VMs so that we can host more VMs past the actual, fixed memory of a host. Memory over commit in AHV first appeared in version 6.02, but was only available via ACLI and the API. With PC 2021.12, we now have it exposed in the UX, as you can see in the example if you're looking at the slide. So this, as said before, allows you to share the memory, unused memory from VMs. It will be able to share up to 75% of a VM's memory if that is unused. So in a sense, if you think about it this way, 25% will always be fixed of the assigned memory for that. It is adaptive sharing, so the host will gradually share more as it monitors a VM's memory usage, and then just take away a little bit more gradually over time as it recognizes that it's using the amount of memory that it is. Said you can do it via UX and PC, ACLI, or via the API. It does not affect the performance of VMs that have fixed memory assignment, but if you do share memory from VMs, it does have some performance impact for the VMs that it has it turned on. It's various on how that happens, so I'll talk about that in other slides. And then briefly, there are 2 mechanisms, balloon driver and host swap, which we're going to dive into in the following slides. So VMs can be shrunk in one of 2 ways. If they have the balloon driver installed, then that will facilitate the shrinking of memory within inside that VM. The balloon driver is installed if you're using the VirtIO drivers, so if you have NGT installed, that's how that's going to work. If you do not have a balloon driver inside the VM, then the host will use a different mechanism called host swap. This does have a higher performance impact because it's essentially forcing the memory swap to give it an option. VM memory is assigned via two controls. ADS is going to create a memory pool, which is equal to the amount of memory within the hosts, and then assign memory out of that to the overcommitted VMs. And then AHV is going to control the overcommit for every VM on the host, and then make sure that it doesn't exceed the physical memory from that memory pool limit. Now we'll take a brief look at the two different reclamation techniques. So the first one is ballooning. So you have the VirtIO balloon driver installed inside your VM. The VM can choose to give up memory because it's monitoring its memory usage and understands I'm not using this memory. So when the AHV host asks, hey, can you give me some memory? It's aware of its usage and can give some of that memory up. So it will, shrink down. It's essentially doing that with a contract of, I can pretty much guarantee that I'm not going to immediately need to use some of this memory, so I'll give it to you. So that's why it's less likely to have swapping. And then the guest is cooperating with the host. Now that monitoring is lost when the guest reboots, so it could peak above what was promised not to use, because when you're starting the OS back up again, it could surge memory and go above what was monitored previously while it was running in steady state. The second one is Hypervisor Swap, right? So there's no balloon driver in there, so it's really just taking a portion of the assigned memory that the host thinks it's not going to use, and it's going to put that on a swap disk on Hypervisor Swap. So it has a much larger performance impact, but does not require the balloon driver and will work for any type of guest that you have running on AHV. A bit more about how the host does its memory management. So the host divides its memory up into two regions, one for VMs with fixed memory assignment and the other for overcommitted VMs. ADS will control that pool, and it makes changes to the pool in the order of minutes. So that's how quickly ADS will react for HA guarantees and such. Squeezer D is the service that's controlling that memory overcommit, and it's going to monitor and make changes within the VMs in the order of seconds, so much faster than ADS is going to react. And then Squeezer D strives to keep a small amount of buffer memory, you can see in the little graph there, so that it's unused, and then if a VM needs to quickly grow, it can pull it from that buffer pool rather than trying to shrink another VM in order to get memory to assign it to the one that was asking for it, which would be much slower and have a larger performance impact. Hello and welcome to new stuff for Feat 3757. This is VM to host Affinity policies in Prism Central for AHV. So why do we need this feature? Well, doing the policies previously that started way back in the 5.0 days, you had to do them in Prism Element, and you had to do them per VM. So if you were managing a large number of VMs on a bunch of different clusters, it would be very cumbersome to go back and adjust those policies. By moving them into PC, where everything is going these days, you're able to use rules and categories to assign these to groups of hosts and groups of VMs, and then all you have to do is come back and change the rules. So much more simpler how we do other policies in Prism Central. To do this, you'll need AOS 6.1 and then PC 2021.12, which will be released in conjunction with 6.1. And it's just for AHV, so that's pretty clear, and is releasing in 6.1. So this is done very similar to how we do other policies in Prism Central. So we'll go through this, quickly. So you would essentially have the workflow of how you do this. You create a category, for VMs. You then attach those to a VM or multiple VMs. Create a category for hosts, and then attach those to a group of hosts. And then you can now create your host affinity policy, and then pick those categories that you picked, which will then pull in all the hosts and VMs that you tagged. You can obviously go back and add hosts and VMs to the policy once it already exists. And then you can create, things can be part of multiple policies, right? So you could have multiple categories, which would be different groups of VMs, different groups of hosts in a policy to make it, more flexible for edge situations. So once the policy is existing, you can check its compliance by looking at the policies page, and it will tell you what's going on. VMs, part of the policy, will show up in there and then show their compliance page, right? So you may have 10 VMs, but maybe only 8 of them are compliant. So the other 2, it's going to give you some direction on why they're non-compliant. Some of those reasons would be the PE could be on too old of a version, so it's not supported. The VM may have multiple affinity policies, and I will tell you how that's going to play out in following slides. Maybe a VM couldn't be powered on because it couldn't be migrated to one of the hosts defined in the policy, or there's just no host defined as part of the policy. Once an admin resolves the issue with why that VM is not compliant, then the policy can be reapplied from Prism, and then it should correct itself. These host affinity policies are, hard type enforcement. So for a powered off VM, when you choose to power it on, if it's not able to be migrated to one of the defined hosts, or there's not enough resources on any of those hosts for it to be powered on, then the VM will not be powered on. If a VM is already powered on and you enforce the affinity rule on that VM, and it can't be migrated to one of the VMs for any number of reasons, then the VM will remain powered on but be marked as non-compliant with the policy. Only Prism admins can perform these operations today because we don't support RBAC on these policies yet. So it is possible for a VM to be part of multiple host affinity policies in Prism Central. The oldest policy is the one that will be applied. The other one, and take action. The other ones are applied, but the VM will be shown as non-compliant with those newer policies. Users can still create the legacy host affinity rules in Prism Element. And then if a VM is already part of a legacy affinity rule, the new host affinity in Prism Central won't overwrite that. It will just apply it, and then the VM will show as non-compliant with the new policy in PC. If a VM is having a rule configured in Prism Central, then once that's applied, then if a user went to Prism Element and tried to configure the rule, that would be blocked there for them because it knows that one exists in PC, which is the new preferred way. In Prism Central, the Affinity Policies UI will provide a mechanism to delete these legacy PE rules on that VM so that when you apply it, then everything will become compliant and it can do its job.